Hi, my name is Milo, and I'm an intern at the San Francisco Public Library. Today, I will be presenting a STEM challenge video. In this video, I want to show you a simulation of Boids. Boids is a contraction of bird-oid, or something that is bird-like. In other words, Boids is an algorithm that is designed to recreate a pattern from life, which is how birds fly together in clumps. Let me show you a demo of what a flock of Boids looks like, and then I'll try to explain how it works. Here we see a group of Boids that start to form small clumps and then eventually group into one larger clump. It looks really complicated because there are a lot of moving little particles, but it's actually made of really just three simple rules: separation, alignment, and cohesion. Let's break that down. Before we can explain those rules, I want to briefly explain vectors. This will become important in a moment. You can think of vectors like an arrow. They have an x component and a y component, and basically can just point in a direction with some length, like this. A Boid is described by two vectors, its position in x and y, and its velocity in x and y. The velocity is just how fast the Boid is moving. So at every instant, you add the Boid's x velocity to its x position, and its y velocity to its y position. Do this over and over, and you get a Boid that moves in a certain direction. Now, back to the rules. To demonstrate the first rule, let's start with two circles. The first rule is that Boids try to separate from one another. This means that these two circles want to separate like this. For all Boids within a certain radius, we take the distance between the Boids, then set the length to 1 over the distance. So for a distance of Boids of 0.5, the length would be 2. We add that distance to the Boid's velocity. The second rule is that Boids try to align with each other. This means that two Boids want to start moving in the same direction like this. The way this rule works is we just average the velocity of all Boids in a certain radius. To do that, we take all their arrows, add the x components up, and divide by the number there are, add the y components up, and divide by the number there are. Then we add that average to our velocity by adding the x components and the y components separately. Finally, the last rule is that Boids want to cohese, or move closer to the center of a group of Boids. To do this, we take the average of the distance to nearby Boids within a certain radius. So we do this in the same way as in Rule 2. You add up the distances to each of the nearby Boids and divide by the number there are. When we combine these three rules, we get what is called emergent behavior. This is what you saw at the start of the video, where Boids can slowly group up and fly together, or sometimes ungroup when they hit a wall. I hope you enjoyed watching the Boids. Be sure to check out the rest of the STEM Challenge Yourself videos by SFPL librarians and Yale interns.